Hello, Math 171. I'm getting a few questions on composite and especially on how to find a domain. So I just want to kind of briefly kind of recap how to find a domain with composite functions. So let's first kind of go over the domain aspect. There are three cases where the domain will cause, I say, a red flag or issue. It's when you have fraction, an even root, and a denominator, which means that if I plug in a number, what number do you think that's going to make this function give it like a red flag? Well, if I plug in 5, if I set this equal to 0 and plug in 5, that have a 0 on the bottom. A 0 on the bottom of the denominator for a fraction is considered to be undefined. And here, what do we know about square roots? You cannot have a negative inside. So if I set the function inside greater than or equal to 0, I know anything that is greater than 0 is considered to be positive, which I can put inside of the square root, which will not make it negative. For the last case, it cannot be a negative inside. Also, it can't be a 0 on the bottom. So this is why we designate it to be greater than. So I'll set the inside of the square root greater than 0, solve, and I figure out my number. For this one, it'll be 5. This one will be -3, and this one will be 2. These are only numbers that's going to call us a red flag for each one of these functions, for example. All other cases, the domain is considered to be all real numbers. So if you don't see a fraction, you don't see a square root, and you don't see a square root plus and a fraction, then the answer is pretty much going to be all real numbers, and we designate it to be negative infinity to positive infinity. So now let's move towards the composite. Given these functions, composite of g and composite of g of x, find the domain of each. Well, after we find the composite, so if I find the composite of the first one, I'll plug g inside of here. This is what I did here. This is 1 over x. Then I simplify it. I get down to the composite of f of g is 3x over x minus 7. Now we're trying to find the domain. Well, if I find one of the ways you have to find the domain is we have to make sure we focus on the domain of both functions and the second function. So for instance, if I'm talking about this one and I need to find the domain, f of g, I need to find the domain of both of them together once we do the math. And I have to combine it with the domain of g of x. Both of these together can create the domain of f of g. Same thing for I would do g of f. That means the second one is the function. So the second one here, second. Find the domain of both of them together, do the math, do the substitution, and then we have to find the domain of f of x. Then we put them together, that creates the domain. So the first one, we're going to find the domain of the together, which I mean here, what down here is going to make it, I give it a red flag? It'll probably be 7, because if you plug 7 minus 7, doesn't that create 0 on the bottom? So we can't have 0 as one of our answers for the domain. If I go back to the second part up here, 0 again down here, if x equals 0, cannot be the function. So I'm going to go from negative infinity to 0 because it won't work for this one. Then 0 to 7 because it won't work for this one. The 7 won't work for here. And then from 7 to infinity. All of the numbers in between will work for both of these functions. It's just you can't use 0 and 7. Same thing over here when we do g of f. I need to find the domain of both first. Since there's no x on the bottom, I don't have to worry about the domain for this one. However, if I go back to the second one, remember the second one, both in second. The second one here, if I set this bottom part equal to 0, my domain is going to be all the numbers except for 1 over 7. Because if I put 1 over 7, that's giving me 1. 1 minus 1 is 0 on the bottom, red flag. So for this one and this one combined, I can go from negative infinity to 1 over 7. Stop, then combine or union 1 over 7 to positive infinity. So hopefully that will help you understand a little bit about how to find the domain of composites.